Good morning and Jai Hind to all. Today we are to discuss a new chapter, Relations and Function. The basis of this chapter is already learned in our first year class. Sets, relations and function. On sets, relations and function. Where there we discuss what is it, types of sets, what is a Cartesian product, what is a relation, and domain, range, function, different types of function. Now, here we discuss types of relations and different types of function. Before starting this chapter, we remain some portions on the first year class. You already know what is set. Using sets, here we form Cartesian product. What is Cartesian product? Suppose you take A is equal to set 1, 2, 3 and B is equal to 3 or two finite sets. What is the definition of Cartesian product? Cartesian product mean or cross product mean set of all ordered pairs of the two sets A and B. That means collection of ordered pairs formed using these two sets. That means A cross B is equal to set of all ordered pairs of A and B. That is collection of ordered pairs. That is 1, 3, 2, 3 and 3, 3 is A cross B. Here A cross B contain 3 elements. Using these 3 elements, we form relation. Definition of relation state subset of A cross B is called a relation. Definition of relation state subset of A cross B is called a relation. Here how many subset can form using this A cross B? Here this A cross B contain 3 elements. If a total number of subset is equal to 2 raised to 3. You know, if a set A contain n element, total number of subset is 2 raised to n. Isn't that formula? This A cross B contain 3 elements and therefore we get total number of subset is 2 raised to 3, answer become 8. 8 subset can be formed. Here the first subset, that is suppose you denote R1 is null set. Then second is R2 contain one element 1, 3. R3 is equal to 2, 3. R4 is equal to 3, 3. R5 is equal to contain 2 elements 1, 3, 2, 3. R6 equal to 2, 3, 3, 3. Then R7 is here 1, 3, 2, 3, 2, 3 and 1, 3, 3, 3. And last R8 contain all elements 1, 3, 2, 3 and 3, 3. These relations are said to be, these subsets are said to be relations. Because the definition is subset of A cross B is called a relation. That means these R1, R2, R3, R4, R5, R6, R7, R8. These are subset and these subsets are said to be relation. A subset of A cross B is called relation. Here we write these relations in roster form. There are two-way representation in relation. First is roster form and second is set builder form. These relations can be written in the second method, that is in set builder form. These are written another way, that means x such that, using the representation x such that. Okay, I will write one more question based on this relation. That is, suppose A is equal to 1, 2, 3, 4, 5, etc. up to 14. is a finite set. We form a relation R from A to A. That means the second set B is also equal to A to A by R is equal to x comma y such that y is equal to 3x bar x comma y is an element of the given set A. Write the roster form of this relation. Here we form, how many relations can be formed using the subset condition? 2 raised to n, the 2 raised to a cross a, that is 2 raised to 14 into 14, that is 2 raised to 196 relation can be formed using these sets. From this 2 raised to 196 relation, we can write only one relation, which is in the set builder form. Convert this set builder form to roster form. That is, how can we form this relation in roster form? Our condition is y is equal to 3x. Here one condition, general condition is y is equal to 3x. First we put x is equal to 1 and therefore y is equal to, we get answer 3. Then x is equal to 2, y is equal to, we get answer 3 into 2 is 6. Then x is equal to 3, y is equal to, we get answer 3 into 3 9. X is equal to 4, y is equal to answer 3 into 4 12. When x is equal to 5, y is equal to, we get answer 15, which is 15 is not an element of the given set, and that means we get how many variables, that is R is equal to, our required relation R is 1 3, second is 2 6, third is 3 9, and fourth element is 4 12. Okay, which is the required relation. Okay. Here A is equal to 1 to 14 is a given set. Using these sets, we here given the set builder form of a relation R is equal to xy such that y is equal to 3x. The roster form of this relation is y is equal to, R is equal to 1 3, 2 6, 3 9 and 4 12. Okay, I'll write one more question. Let me form a relation. If form a relation n is A is equal to n. A is any set, that is set is equal to set of all natural numbers. Here we form a relation R from A to A, that means n to n, A to A, A to A. We form a relation R from A to A. A is equal to n, we form a relation R from A to A by R is equal to x such that, xy such that y is equal to x. X comma y is an element of the given set A. Write this roster form. Write the roster form of this relation. Here the roster form is R is equal to, the first natural number is 1 and therefore this image is also 1. Next is 2, 2, then 3, 3, then 4, 4, etc. It's a relation. Here R is equal to xy such that x is equal to y is in the set builder form. It is converted in the roster form. R is equal to 1, 1, 2, 2, 3, 3, 4, 4, etc. Here the x component are domain and y coordinate are codomain. Okay. Now write one more question. A is equal to set 1, 2, 3, 4, 5. Define a relation R from A to A by R is equal to x comma y such that y is equal to x plus 1. X comma y is an element of the given set A. Find its roster form. Okay. Here given condition is y is equal to x plus 1. Here given condition y is equal to x plus 1. First we take x is equal to 1. X is equal to 1 is an element of the given set A and therefore y is equal to 1 plus 1 is answer 2. 2 is also an element of the given set A. Next we take x is equal to 2 and therefore y is equal to 2 plus 1 answer 3. x is equal to 3, y is equal to, we get answer 3 plus 1 is 4. Then x is equal to 4, we get y is equal to 5. Then you say x equal to 5, y becomes 6 is not an element of the given set A, and therefore the given, the required relation is 1, 2, 2, 3, 3, 4 and 4, 5. That's all. It is a roster form of the given relation. In this way, we find roster form and set-builder form of relation. These are the portions on the first year class. Now, we start the second year portion. In second year, we discuss types of relation. There are different types of relations here. First is empty relation, second is universal relation, third is reflexive relation, then symmetric relation and transitive relation. Then if a relation satisfies reflexive, symmetric and transitive, then that relation is to be an equivalence relation. Okay, here we discuss the definition of these types of relation and the problems are based on these types of relation. Okay, these are only a basis portion. These portions are already learned in our first year class. Now start second year portion. First, types of relation. Our first types of relation is empty relation. Empty relation or void relation. Empty relation or void relation. What is empty relation? A relation R on set A is called empty relation if no element of A is related to any element of A. Definition state, a relation R on set A is called empty relation if no element of A is related to any element of A. That means, suppose A is equal to taken set 1, 2, 3. Here we form a relation R is equal to x comma y such that x comma y such that x plus y is equal to 12, comma x comma y element of the given set A. Check this relation is empty or not. First we form A cross A, that means Cartesian product, A cross A. Here what is A cross A? A cross A means set 1, 2, 3 cross 1, 2, 3 is equal to, we get 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2 and 3, 3. Now we find the roster form of the given relation. Roster form condition is x plus y equal to 12. You check each pair which pair satisfy this condition. 1 plus 1 equal to 12? No. 1 plus 2, 1 plus 3, 2 plus 1, 2 plus 2, 3 plus 3, 3 plus 1, 3 plus 2, 3 plus 3. No pair satisfy this condition and therefore the relation become R is equal to, this roster form R is equal to, answer is null set, that is empty relation. That means a relation R on a set A is to be empty relation if no element of A is related to any element. Here each one is not related to 1, one is not related to 2, one is not related to 3. Similarly all of them, each element is not related to any element of the given set A, and therefore that means there is no element, there is no ordered pair can be formed. Such type of relation is said to be empty relation. It is the first definition, first types of relation. Okay. Now the second relation is universal relation. universal relation. What is universal relation? Universal relation definition states that a relation R, a relation capital R on set A is called universal relation if each element of A is related to every element of A. Each element of A is related to every element of A. That means here we consider set A is equal to 1, 2, 3. We simply write a simple here write A is equal to 1, 2. We form a relation R is equal to x comma y such that x plus y greater than 0, x comma y element of the given set A. Okay, first we find A cross A. That means set 1, 2 cross 1, 2 is equal to, we form collection ordered pair 1, 1, 1, 2, 2, 1 and 2, 2. Now check, now find the roster form of this relation. How many ordered pairs satisfy this condition? That is, now the relation R is equal to x plus y greater than 0. Here 1 plus 1 is no, 1 plus 1 is greater than 0. That is the first pair. Now 1 plus 2 is also greater than 0. That is second pair. 2 plus 1 is also greater than 0. It's the third pair. And last 2, 2 is also satisfy the given condition. That means each element of set A is related to every element of that set. That means here R is equal to that A cross A. This type of relation is called universal relation. Okay, that is here each element of A is related to every element of that set A. This relation is called, that means A cross A itself is called universal relation. If you know a relation contains no element, it is called empty relation, and the relation contains all the elements of that A cross B or A cross A is called universal relation. Okay, now we discuss a new types of relation. These are all very important relation. Next type is reflexive relation. Reflexive relation. Reflexive relation. What is reflexive relation? It is very important relation. Reflexive relation. What is reflexive? Here definition states that a relation R in a set A is said to be reflexive, is called a reflexive relation if A related to A. A related to A. A related to A. That is, ordered pair A is an element of the given relation. For all A is an element of A. That's the definition. That means, suppose here we consider a set 1, 2, 3. Using these sets we form a relation from A to A. How many relations can be formed? That is 2 raised to n of A into n of A. That is 3 into 3, 2 raised to 9. 2 raised to 9 means that approximately, 5 total relations can be formed. Okay, from this relation, right to 3 relations. That is, using these sets we form 3 relations. We consider 3 relations. First is 1, 1, 1, 2, 2, 1 and 2, 2, which is the first relation. Also, write one more pair, one more pair, that is 3, 3 also. Okay. Now the second relation, R2 is equal to 1, 2, 2, 1, 3, 2. Okay. Then R3 is equal to 1, 1. Okay. You check these 3 relations are reflexive or not. Reflexive definition says that ordered pair A element of R for all A is an element of the given set A. A എന്ന സെറ്റിനകത്തുള്ള കംപ്ലീറ്റ് എലമെൻസും റിലേറ്റഡ് ആയിട്ട് വരുന്ന പേഴ്സ് ഈ പറയുന്ന റിലേഷനകത്ത് കണ്ടെയ്ൻ ചെയ്യണം. ദാറ്റ് മീൻ എ സെറ്റ് കണ്ടെയ്ൻ ചെയ്തിട്ടുള്ള എലമെൻറ്റ്സ് 1, 2 and 3. എയിലുള്ള കംപ്ലീറ്റ് എലമെൻറ്റ്സ് പരസ്പരം റിലേറ്റഡ് ആയിട്ടുള്ള പേഴ്സ്, ദാറ്റ് ഈസ് 1, 1 റിലേറ്റഡ് ആയിട്ടുള്ള പെയർ, 2, 2 റിലേറ്റഡ് ആയിട്ടുള്ള പെയർ, 3, 3 റിലേറ്റഡ് ആയിട്ട് പെയർ. ദാറ്റ് മീൻ ഓൾറെഡി പെയർ 1, 1 കണ്ടെയ്ൻ ചെയ്യണം റിലേഷനിൽ, 2, 2 കണ്ടെയ്ൻ ചെയ്യണം and 3, 3 കണ്ടെയ്ൻ ചെയ്ത് കഴിഞ്ഞാൽ that types of relation is said to be reflexive. The first relation 1, 1 കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ട്, 2, 2 is already contained, 3, 3 also contained. That means this relation is said to be reflexive. But in second relation 1, 1, 2, 2, 3, 3 കണ്ടെയ്ൻ ചെയ്തിട്ടില്ല, that relation is not reflexive. It is reflexive, is not reflexive. And third ആകെ 1, 1 മാത്രമേ കണ്ടെയ്ൻ ചെയ്തിട്ടുള്ളൂ, കംപ്ലീറ്റ് എലമെൻസും കണ്ടെയ്ൻ ചെയ്യണം, 1, 1 കണ്ടെയ്ൻ ചെയ്യണം, 2, 2 കണ്ടെയ്ൻ ചെയ്യണം, 3, 3 കണ്ടെയ്ൻ ചെയ്യണം. ഇല്ലെങ്കിൽ ഒരു പെയർ കണ്ടെയ്ൻ ചെയ്തിട്ടില്ലെങ്കിൽ അത്തരം റിലേഷൻസ് ആർ നോട്ട് റിഫ്ലക്സീവ്. R3 റിലേഷനിലും റിലേഷൻ ഈസ് നോട്ട് റിഫ്ലക്സീവ്. ഇപ്പോൾ റിഫ്ലക്സീവ് കണ്ടീഷൻ ഇത്രയേ ഉള്ളൂ. എ റിലേഷൻ R ഈസ് ടു ബി റിഫ്ലക്സീവ് ഇഫ് എ റിലേറ്റഡ് ടു എ. ദാറ്റ് മീൻ ഓരോ എലമെൻറ്റ് അയാളുമായിട്ട് റിലേറ്റഡ് ആവണം. ഇൻ ഷോർട്ടിൽ നമുക്ക് എന്ത് പറയാം, ഓൾറെഡി പെയർ എ റിലേഷൻ അത് കണ്ടെയ്ൻ ചെയ്യണം. ഇപ്പോൾ സപ്പോസ് സെറ്റ് ഈസ് നോട്ട് ഗിവൺ, എ നിങ്ങളുടെ സെറ്റ് നിങ്ങൾക്ക് തന്നിട്ടില്ല എന്നുണ്ടെങ്കിൽ, ഇപ്പോൾ സപ്പോസ് എ ഈസ് നോട്ട് ഗിവൺ, ഈ കൺസിഡർ ഓൺലി റിലേഷൻ R is equal to 1, 2, 2, 1, 2, 2, 3, 1, 3, 3 and 1, 1. Check whether the relation is reflexive or not. ആ ടൈമിൽ ഇതിനകത്തുള്ള റിലേറ്റഡ് എലമെൻറ്റ്സ് ചെക്ക് ചെയ്യുക. റിലേറ്റഡ് എലമെൻറ്റ്സ് 1, 2 ആയിട്ട് റിലേറ്റഡ് ആണ്, 2 ആയിട്ട് റിലേറ്റഡ് ആണ്, 3 ആൾസോ റിലേറ്റഡ് ടു 1 ആണ്. സോ ദ റിലേറ്റഡ് എലമെൻറ്റ്സ് ആർ 1, 2 and 3. ആ എലമെൻറ്റ്സ് പരസ്പരം റിലേറ്റഡ് ആയിട്ടുള്ള പെയർ നിങ്ങൾ റിലേഷനകത്ത് കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ടോ എന്ന് ചെക്ക് ചെയ്യുക. ദാറ്റ് മീൻസ് 1, 1 ഉണ്ടാവണം, 2, 2 and 3, 3 കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ ദാറ്റ് റിലേഷൻ ഈസ് റിഫ്ലക്സീവ്. ഹിയർ 1, 1 കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ട്, 2, 2 കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ട് and 3, 3 is contained. So the relation is to be reflexive. Okay, then what is a reflexive relation? A relation R in a set A is to be reflexive. Condition is A related to A. That means ordered pair AA must become an element of the given relation. Okay, write one more question. Suppose A is equal to 1, 2, 3, 4. Here I write a relation R is equal to, R1 is equal to 1, 1, 2, 2, 3, 3, 4, 1, 4, 2 and 4, 4. Okay, R2 is equal to 2, 2, 3, 3 and 4, 4. R3 is equal to 1, 1, 2, 1, 3, 3 and 4, 4. Okay, here R1, R2 and R3 are given. Check these relations satisfy reflexive condition. Here the first relation already satisfy reflexive condition because it contain 1, 1, 2, 2, 3, 3 and 4, 4. The set A contain 1, 2, 3, 4. Therefore each element is related to itself. That means 1, 1 ഉണ്ടാവണം, 2, 2, 3, 3 and 4, 4 contain ചെയ്തിട്ടുണ്ട്. R1 is reflexive relation. But in second and third, here 1, 1 is not an element of the given relation R2 and therefore R2 is not reflexive. Also R3 is not reflexive because here 2, 2 is not an element of the relation R3 and therefore R3 is not reflexive. Okay, clear? Now the second, now the next types of relation is symmetric relation. Symmetric relation. Symmetric relation. What is symmetric relation? The definition said a relation R on a set A is called a symmetric relation if A related to B implies B related to A. A related to B implies A related to B implies B related to A. That means ordered pair AB element of R implies ordered pair BA element of R. Simple. എ ബി എന്നുള്ള ഓർഡർ പെയർ റിലേഷനിൽ കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ ഓട്ടോമാറ്റിക്കായിട്ട് ബി എയും അതിൻ്റെ റിവേഴ്സ് ഓർഡറായ ബി എയും കണ്ടെയ്ൻ ചെയ്യണം. ദാറ്റ് ഈസ് സിമെട്രിക് റിലേഷൻ. Let me suppose we take an example. A is equal to, suppose it 1 2 3 and a relation R1 is equal to 1 1 1 2 2 1 3 1 1 3 and R2 is equal to 2 1 3 sorry 3 1 3 2 2 3. R3 is equal to 1 1 2 2 3 3. Check whether R1, R2 and R3 are symmetric or not. Symmetric definition states that if AB is an element of the given relation, then compulsory BA is also an element of that relation. Here the first relation 1 1 is reversing the x and y component, we get 1 1 is also an element of that relation. 1 2 reversing 2 1 is also an element. 2 1 1 2 is an element. 3 1 1 3 is an element, is reversing the pair. Then 1 3 is a reverse order is 3 1 is also an element, and therefore given relation R1 satisfy symmetric condition. Here the complete elements relation contain elements in the reverse order check here. 1 on reverse order 1 1 1 2 in the reverse order 2 1 2 1 in the reverse order 1 2 3 1 into the 1 3 1 3 in the reverse order 3 1. So all complete pairs in the reverse order ഈ പറയുന്ന relation അത് contain ചെയ്തിട്ടുള്ളതുകൊണ്ട് ഈ പറയുന്ന relation എന്താണ് symmetric relation satisfy ചെയ്യുന്നുണ്ട്. But in R2 2 1 contain ചെയ്തിട്ടുണ്ട്, but it's reverse order 1 2 1 2 is not an element of R2. It's to one condition failure ആയതന്നെ ഈ പറയുന്ന relation നമുക്ക് എന്താ പറയാം is not symmetric. Here 1 2 1 is an element of R, but 1 2 is not an element of R. Also 3 1 is an element of R, 1 3 is not an element of R. 3 2 and 2 3 okay, but 2 1 here the only condition 2 1 is an element of R, but 1 2 is not an element of R and R2, and therefore given relation is not symmetric. Here if you satisfy, so suppose the first R1 satisfy the symmetric condition, then we write generally the answer. That means here 1 1 1 2 2 1 3 1 3. That means symmetric condition satisfy this relation. Therefore we write the answer as here AB element of R implies BA element of R, and therefore R is symmetric. In that case answer become AB element of R implies BA element of R, and therefore R is symmetric. But in second case R2 contradiction, here 2 1 is element of R2, but the reverse order 1 2 is not an element of R2, and therefore this relation is not but in R3 1 1 is a reverse order is 1 1, 2 2 is also 2 2 is an element of R, 3 3 is reverse order also 3 3. That means these three elements, three pairs satisfy the symmetric condition. Here we write AB is an element of R implies BA is an element of R, R3, and therefore given relation is satisfy symmetric condition. Okay, clear? Now write one more question on based on symmetric. Here we write A is equal to 1 2 3. Here R1 is equal to 1 1 1 2 2 2 3 2 and 2 3. R2 is equal to R2 is equal to 2 2 3 2 2 3 3 3. R3 is equal to 1 1 1 2 2 1 3 2 2 3. Check these three relations satisfy symmetric condition. The first relation R1, check the relation satisfy symmetric condition. Okay, 1 1 is a reverse order is 1 1. Okay, 1 2 but is a reverse order is 2 1. That pair is not an element of R1. Therefore here we write here 1 2. Here 1 2 is an element of R1, but is reverse order 2 1 is not an element of R1 and therefore R1 is not symmetric. R1 is not symmetric. Okay. Now second relation R2. Here 2 2 reverse order is 2 2, 3 2 reverse is 2 3, 2 3 reverse order 3 2, 3 3 reverse is also 3 3. That means AB element of R implies B element of R is satisfy the condition. Here if we write answer become generally. If the relation satisfies the condition of symmetry or reflexivity, then we write the answer become generally. That is, here we write AB is an element of R2 implies BA is an element of R2 and therefore R2 is symmetric. R2 is symmetric. But in third relation R3, 1 1 is reverse order is 1 1, 1 2 is reverse is 2 1, 2 1 reverse order is 1 2, 3 2 reverse is 2 3 and also 2 3 reverse order is 3 2. That means R3 satisfy condition for symmetric. Here we write here AB element of R3 implies BA element of R3 and therefore that implies R3 is a symmetric relation. R3 is a symmetric relation. Okay. If suppose ഏതെങ്കിലും ഒരു relation contradict ചെയ്യുന്ന കേസിൽ മാത്രം ഏതെങ്കിലും ഒരു particular pair the first relation വന്നിട്ട് 1 2 is an element of R1 പക്ഷേ അതിൻ്റെ reverse order 2 1 is not an element of R1 and therefore that relation is not a symmetric. Okay, but എല്ലാ കണ്ടീഷനും സാറ്റിസ്ഫൈ കംപ്ലീറ്റ് പെയറും സിമെട്രിയുടെ കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ടെങ്കിൽ ജനറലായിട്ട് ആൻസർ എഴുതുക. ദാറ്റ് ഈസ് എ ബി എലമെൻറ്റ് ഓഫ് R2 implies B element of R2 and therefore that relation satisfies the symmetric condition and therefore R2 is symmetric. Okay. Now we define the third types of relation, that is transitive relation. Transitive relation. What is transitive relation? A relation R on set A is called a transitive relation if A related to B and B related to C implies A related to C. A related to B comma B related to C implies A related to C. That means ordered pair AB comma ordered pair BC element of R implies ordered pair AC element of R. AB and BC തന്നിരിക്കുന്ന റിലേഷനകത്ത് കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ ഈ രണ്ട് പെയറും കമ്പൈൻ ചെയ്ത് ന്യൂ പെയർ ഫോം ചെയ്യണം. എ സി എയിലും സിയിലുമായിട്ടൊരു പെയർ ഫോം ചെയ്യണം. ദാറ്റ് പെയർ ആ റിലേഷനകത്ത് കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ടെങ്കിൽ സച്ച് ടൈപ്പ് റിലേഷൻസ് ആർ ടു ബി ട്രാൻസിറ്റീവ് റിലേഷൻ. Okay, we write an example. A is equal to 1 2 3. A is equal to 1 2 3. Here we write a relation R is equal to 1 1 1 2 2 1 and 2 2. Check given relation satisfy the condition of transitivity. The condition is AB and BC element of R implies, given relation implies AC element of R. നമ്മൾ പെയർ സെലക്ട് ചെയ്യുക. ആ പെയറിൻ്റെ y കോർഡിനേറ്റ് x കോർഡിനേറ്റ് ആയിട്ടുള്ള സെക്കൻഡ് പെയർ സെലക്ട് ചെയ്യുക. ഇവ രണ്ടും കമ്പൈൻ ചെയ്ത് ന്യൂ പെയർ ഫോം ചെയ്യണം. ദാറ്റ് മീൻ ഹിയർ 1 1 is the first pair and the y coordinate is 1. We select a second pair, that is x coordinate become 1, that is 1 2. 1 2 ൻ്റെ x coordinate is 1. ഈ രണ്ട് പെയറും ഫോം ചെയ്ത് വെച്ചുകൊണ്ട് ന്യൂ പെയർ ഫോം ചെയ്യണം. ദാറ്റ് ഈസ് 1 2. ഈ 1 2 നിൽക്കുന്ന റിലേഷൻ കണ്ടെയ്ൻ ചെയ്തിട്ടുണ്ട് ആൻഡ് ദെയർഫോർ ആ പെയർ ട്രാൻസിറ്റീവ് കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ട്. സെക്കൻഡ് 1 1 വൈ കോർഡിനേറ്റ് 1 ആണ്, എക്സ് കോർഡിനേറ്റ് 1 വരുന്ന വേറെ ഏതെങ്കിലും പെയർ ഉണ്ടോ എന്ന് സെലക്ട് ചെയ്യുക. നോ, there is only one pair. Now the second, we consider the second pair is 1 2. Each element, each pair ഈ ട്രാൻസിറ്റീവ് ചെക്ക് ചെയ്യണം. 1 2. Here the y coordinate is 2. We select next pair, that is x coordinate 2 ആയി കിട്ടുന്ന പെയർ സെലക്ട് ചെയ്യുക. ഇവിടെ രണ്ട് പെയറുകളുണ്ട്, 2 1 ഉണ്ട് 2 2 ഉണ്ട്. ഫസ്റ്റ് നമുക്ക് 2 1 ആയിട്ട് കണക്ട് ചെയ്യാം. 2 1 ആയിട്ട് ലിങ്ക് ചെയ്യുമ്പോൾ we get a new pair, that is 1 1 is also an element of the given relation. That means ആ എലമെൻറ്റും transitive condition satisfied. Again 1 2 is linked with the next pair is 2 2. 2 2 ആയിട്ട് ലിങ്ക് ചെയ്യുമ്പോൾ we get a 1 2 is also an element of that pair, that relation. അതും ട്രാൻസിറ്റീവ് സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ട്. ഓക്കെ, 1 on 1 2 finish. Now we select 2 1. 2 1 എന്ന് വരുമ്പോൾ y coordinate is 1, we select x coordinate 1 ആയിട്ടുള്ള 2 pair 1 1. 1 ആയിട്ട് ലിങ്ക് ചെയ്യുമ്പോൾ we get 2 1. 2 1 is an element of the given relation. Next is again 2 1 is linked with 1 2. We get answer is 2 1. Sorry, 1 2, we get answer 2 2 is also an element of the given relation. And last we connect with 2 2. 2 2 ആയിട്ട് കണക്ട് ചെയ്ത് നമുക്ക് ഒരൊറ്റ എലമെൻറ്റേ ഉള്ളൂ 2 1. 2 കാരണം 2 2ൻ്റെ y കോർഡിനേറ്റ് 2 ആണ്. എക്സ് കോർഡിനേറ്റ് 2 വരുന്ന പേരിട്ട് വേണമെങ്കിൽ നമുക്ക് കണക്ട് ചെയ്യാൻ. എക്സ് കോർഡിനേറ്റ് പേര് വരുന്നത് 2 1 ആണ്. 2 1 ആയിട്ട് കണക്ട് ചെയ്യുമ്പോൾ വി ഗെറ്റ് 2 1 എന്നുള്ള പേര് തന്നെ കിട്ടുന്നുണ്ട്. ഈ കംപ്ലീറ്റ് എലമെൻറ്റ്സ് നമ്മൾ ലിങ്ക് ചെയ്ത് കിട്ടുന്ന ന്യൂ പെയർ, തേർഡ് പെയർ കമ്പൾസറി ഈ പറയുന്ന റിലേഷനകത്ത് വരുന്നത് കൊണ്ട് തന്നെ ഈ പറയുന്ന റിലേഷൻ എന്ത് സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ട്? ട്രാൻസിറ്റീവിൻ്റെ കണ്ടീഷൻ സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ട്. R1. Suppose you take R2 is equal to ഞാനൊരു കണ്ടീഷൻ എടുക്കുകയാണ് 1 2 and 2 3. Check whether the relation R2 is satisfy the condition of transitivity. Okay, here 1 2. 1 2 ലിങ്ക് ചെയ്യാനായിട്ട് y coordinate become 2 and x coordinate 2 ആയിട്ടുള്ള പെയർ സെലക്ട് ചെയ്യുക. x coordinate 2 ആയിട്ടുള്ള പെയർ ഇവിടെ വന്നിട്ട് 2 3 ആണ്. ലിങ്ക് ചെയ്ത് കിട്ടുന്ന ന്യൂ പെയർ എന്ന് പറഞ്ഞാൽ 1 3. But here 1 3 is not an element of R2 and therefore R2 is not transitive. Here we write 1 2, here we write 1 2 and 2 3 is an element of R2. Their combined pair 1 3 is not an element of R2 and therefore R2 is not transitive. But in R1, which satisfy all the elements satisfy the condition of transitivity. So here we generally we write AB and BC element of R1 implies AC element of R. Okay, AB BC element of R1 implies AC element of R. But in R2 we write But in R2 we write here 1 2, 2 3 is an element of R2, but their combined pair new pair 1 3 is not an element of R2 and therefore R2 is not transitive. Here first we write here all the elements satisfy the condition of transitivity. That means generally we write here AB definition. Our definition we write here we write the definition AB, BC an element of R1 implies AC element of R and therefore R1 is transitive. Okay. Actually these three types of relation, I mean reflexive, last define three types of relations are reflexive, symmetric and transitive are very important. These are connected with many other application level. That mean simply we write reflexive mean an element is related itself. Symmetric mean any element is related to second and second is also related to first. Transitive means a relation first is related to second and second is related to third, then automatically first is related to third, you get a transitive condition. Now we discuss more problems based on this topic. Will be on the next class. We want to discuss more and more problem, then we get more idea about this.